Good evening, Uma. Uma, can you hear me? Hello.
Hello. Hi. Hi, Sri.
Hey, Uma. Just Jahnavi is just joining, and we have Prasanna also. She
Sorry.
will join.
Okay.
Prasanna,
Okay.
so he may join,
Okay.
but we'll start anyway. Good evening, Jahnavi.
Yeah, good evening, ma'am.
Is that okay?
Yeah, okay.
You got a chance to practice what we discussed in the
Uh,
bench?
yeah, little bit.
Okay, so okay. But please practice if you have not practiced, okay?
Sure,
Today,
sure.
yeah, today I want to start with the PySpark, which I mentioned already. And coming to like PySpark, there are so many reasons why PySpark is very popular in the market. And we learned about the fundamentals of very basic fundamentals of the PySpark, which is required at high level. And today I'm going to start the. Hey Prasanna, good evening.
Actually, good evening.
Yeah, thank you. Okay, so we are just starting PySpark today, and which we learned about in the previous classes. I hope you had a chance to practice on that. And today we'll move and try to jump into the Spark specifically. Okay. Any challenges with respect to the previous class practice?
I picked up a lot of your scripts and tried with the data frame, so nothing
Okay,
so
cool,
far.
cool. Okay,
Yeah.
okay. Great. Okay, let me share my screen. We have Uma from today. She just joined from today. So welcome, Uma.
Yeah. Hello. Yeah. Sri, is the session will be recorded or?
It will be automatically recorded.
Okay. Okay. Yeah.
Yeah, it will be. Okay, so when I talk about the PySpark, right, which is one of the framework which is very popular. So we have uh, so many tools available in the market, but PySpark is one of the in-memory computing framework, which will basically will help us to process large volume of data. And there are like other frameworks available were available, but why PySpark we'll try to discuss. And before that, moving to that, so why that Spark, which is a part of PySpark, how Spark was like started and how companies started going went for Spark and how it has been like impacted the the traditional database platform and all we'll see. And if you see normal traditional ETL process, right, where you go with regular like uh, data warehousing pipelines, we go with multiple sources will be integrated and they will be pushed into the operational data store, and from there the data will be moved into the a data warehouse by leveraging the staging area, and then finally that will be divided into a group of data marts, and all this will be done through the ETL process. And finally, whatever generated, the transformed data will be separately used by the teams to build their dashboards and reports by leveraging the business intelligence and then most of the visualization tools. So we have tools like Tableau, Power BI, and other tools which will basically do this job. But when you are dealing with normal, specifically structured data and all, generally we go with ETL process, but there are occasions where your data may not be like only structured, right? It can be semi-structured and quasi-structured and unstructured, which is like different varieties of data will be there. At the same time, after 2012-13, what happened? The data volume also increased. So when the data volume increased means the data is not in like big data say means not only like data in GBs. It can be in it will be in the petabytes of data. Then only we can consider that as big data. So when people started leveraging this particular traditional databases, everybody was able to process, but some level only. When data got increased, the traditional databases also started not supporting. And then when people were looking for alternative, that is where Hadoop came into the market. So this Hadoop is nothing but a combination of HDFS and MapReduce generally. So HDFS is the distributed file system, and then the MapReduce is a distributed processing framework. These both together started helping to process the data which is in a high volume and also different varieties with high velocity. So because what will happen in basically in this particular Hadoop environment is it will be distributed with across different machines. Every machine will have its own disk and own memory and CPU, and it will try to process, and then it will try to centralize the data into a particular environment called HDFS. And this process was going smooth for some time, but people were facing some challenges because MapReduce is one of the framework generally people were using to process the large volume of data. But however, MapReduce will go with disk IO operations. Whatever you see, these are all disk IO operations. So the data which will be extracted and then copied into from the disk, it will be copied into memory and it will process again and it will send back the disk. So this process was taking so much amount of time. So when people started using MapReduce, the solution for processing big data was resolved, but at the same time, there was a high latency everybody started experiencing. That latency was not even in minutes, was in hours and hours. So then people started again looking for alternative because the maintenance of this particular big data environment is also not easy. We needed dedicated Hadoop administrators and big data engineers. A separate dedicated team is needed. So then when people are looking for an alternative, so where instead of storing in a disk, why can't we use directly memory itself? So that is where we got Spark into picture. What Spark did is Spark came up with a solution with storing the data directly in the memory and processing it. And every data engineer started using this particular Spark interface and the Spark framework where they started processing the data directly in the RAM, in the memory. And then whatever the data available that was still it was storing in HDFS itself, but the processing engine has been replaced here. But initially also Spark was not with Python, it was with Scala. So because Scala is one of the language where Spark was developed, and the Scala was like helping the people to build this in-memory computing frameworks or data pipelines. So slowly what happens, Scala captured the market with Spark and the people are leveraging it, but some of the programmers or data engineers were not happy with like Scala because Scala is similar to Java, and whoever wants to work on Scala, again they have learning curve, and it can achieve whatever Java can do, but people started thinking, how can't we use another programming language? So that is where Python came into picture. So Python came with integration with Spark. That is where PySpark came into market. And then PySpark is one of the Python library which will help to perform whatever Scala was doing on the big data in-memory computing side. Then PySpark came into the place. And slowly, since Python became popular, PySpark also became popular in the revolution of big data. Now, if you see the market, most of the market, wherever you see, PySpark is helping. And any big data environment, you see, PySpark is very, very popular. In data warehouses, maybe in the first generation, people were using like only SQL. But later we got the data warehouses has been converted to data lakes. And every data lake is not like data warehouse. It is a combination of multiple sources and multiple sources with high volume of data. And that too, we need a commodity storage and cheap storage, and scalability should be there. And we should support different varieties of data like JSON, Parquet, CSV. We have different varieties of data available. So this data lakes started helping in processing different kinds of data. And on top of that, we got lake house also. A data lake has been, then generation 3 became a lake house, which is coming up with a combination of data lake and then data warehouse with ACID properties and with high scalability, and a warehouse with data lake capabilities. So that is where the industry is now slowly moving. If you see, even in Azure side also, we have Azure data lake and storage, and I have one lake in Azure Fabric. So most of these particular environments are storing data in the form of like a high volume with database capabilities. So here this big data management is changed now compared to the earlier process, and at the same time the data volume since increased, we also need to see how to manage it, because not everybody is interested to adapt to the big data directly, and when people wants to migrate to big data, to learning this many framework is not also easy. If you go and see most of the market, the frameworks are very high nowadays. So many frameworks are coming every day. So every day you can't go and learn a new framework, and we can't manage also. But I want to process big data also. Every data warehouse engineer or data engineer, if I ask them to learn all this, they will not be ready. So even companies also facing so many challenges to maintain this. So the infrastructure maintenance is very high. So when PySpark came into the market, the every data engineers started leveraging PySpark, and they started building the data pipelines by writing the code and all. But the challenge was, as I mentioned, the infrastructure management. That is where majorly people were struggling. The infrastructure management, generally, you go and see most of the companies, when they want to build a big data environment, they used to hire a separate big data team, and they used to depend on the big data engineers who can create these data pipelines for migrating from like a group of integrated sources to the Hadoop environment, and that is not happening initially. But whenever the Spark became popular, a group of people who developed Spark started thinking, when the people data engineers are struggling in building this infrastructure, why can't we go and build a separate platform that can help this data engineers to directly go and create pipelines and eliminate the challenges of infrastructure management. So that is where the Databricks started, and the team, when they started, they were looking for the common enterprise level issues or challenges what every company is facing with respect to data engineering. The maintenance cost was growing, the first thing. So they don't want to go and the companies are not ready to go and buy the additional infrastructure, and all ongoing expenses and all was causing some maintenance cost. Second thing, they need to go and do a upfront expenses. A capital investment is important. Every company was not ready to do that, because the initial investment also was very high, and data loss and the risk in the data loss also. If you go and see most of the banks specifically, they will be not ready to disclose their data because data is very sensitive. So some companies if you go and see some clients, they will not be ready to disclose the data. They want their data should be protected and secured. So if you go and see, this is one of the biggest challenge for the data engineers to maintain this data security when they are building the data pipelines, because there might be some hardware failures and disasters will be there and security breaches. So these are all biggest challenges. And one more important challenge is every company will have some limitation to scale up and scale their environment, because the business may not be ready to provide the budget and all. So this is also one of the biggest challenge, to assume my data pipelines require additional infrastructure to scale up. You may not get enough support from the teams. And industry compliance, this is also very, very important, because most of the industry, where they will lack of is the security and regulatory standards will be very difficult to manage, because every country will have their own regulatory standards, the compliance and regulatory standards. So we need to adapt to that, and we need to have a set of tools which can adherence to the industry compliance also. And after all of this, we also will experience some performance optimization required. Performance it will be there if you go with the enterprise level data management. And to maintain all this, we need a separate dedicated extra IT support team also needed, so who can go and monitor this environment. So all these problems, on-premise like problems, this Databricks team has been looked into, and the Spark came into the market, which is a in-memory compute where your data will be processed in the RAM, which will go and run 100 times faster than the traditional disk-based MapReduce processing. That is where the first reason why Spark became popular. Second thing is it supports multiple languages. So I can write Spark code not only in Scala. Initially it was Scala, now later I can write in Java, I can write in R programming, I can write in like SQL. So I can even combine together also. That is one of the another important reason why people move to Spark also. And a unified engine. So if you see before, like Spark was there, people used to use different frameworks for different purpose. If you go and see, MapReduce was processing the data. At the same time, for structured data, people are using RDBMS data, people are using Scoop. For any kind of log processing, Flume was there. For data like column oriented data, HBase. And real-time data, people are using Kafka and Storm. And any kind of SQL kind of analysis people want to do, Hive was there. So like that, every framework was separate. And machine learning, we have Mahout. So every framework was people developed for a purpose. And integrating the services or frameworks is also not easy. So people are facing so many challenges in integrating these different frameworks. At the end of the day, to build a big data environment, people used to struggle a lot. But Spark, when it came to the market, it replaced or eliminated all these pain points. Like for example, one single unified engine for large scale data processing, which can help us to perform the ETL SQL queries. I can use Spark SQL is there, and for machine learning, we have like Spark MLlib, and we also have like data frame processing and RDD processing for unstructured data, and the graph processing is there. And most of the components of Spark will help us to perform any kind of operation. Spark streaming for real-time processing. So Kafka people are using, and Storm for real-time processing. Now Spark streaming also can help us. So it was different frameworks before Spark was there. Now after Spark came to the market, it became one single unified framework to achieve all this. And why Spark also become popular is distributed computing, because the Spark cluster which you are going to submit your data for processing is a combination of multiple nodes and which will use multiple machines to parallelly execute and with distributed computing along with the in-memory capabilities. So all processing will happen in the RAM, which is a very faster compared to the disk-based processing like MapReduce. And third one is like data frame API where I can go and process my data. How we use pandas processing. I can use PySpark also for data frame processing. We have data frame APIs available for the distributed processing specifically. And lazy evaluation. So the processing also, if you go to most of the ETL projects, you will transform the data by applying some transformations. But in Spark, we have transformations which will not immediately applied. They will be applied only a particular action will be executed. So transformations and actions together will help us to go and run the transformations to pre-process the data. But this can be done, a transformation can be executed or actioned only if you try to call an action like a count action or a save action. So we have different actions available to apply some. For example, I want to apply a joint transformation. To apply that, I need to call an action. Without an action, none of the transformations will be directly applied also. So that's coming to Spark architecture. If you see, Spark architecture will come up with a driver and a cluster manager and an executor. These three generally will manage the entire Spark environment. So the driver will behave like a brain which will try to convert your code and it will also schedule your submitted jobs as group of tasks and with the help of a cluster manager. So the cluster manager is the component which will try to allocate the resources required to process the data and according to the executors which will be the actual worker nodes which they will execute the tasks which submitted by the driver and they will store the data intermediately in the memory and then they will return the results back to the driver. So cluster manager just will provide the resources to manage the resources. It can be Yarn, it can be Kubernetes, it can be Mesos. There are different cluster managers are there who will provide like resources required and then the driver with the help of cluster manager, it will try to manage the executors to process the data with different nodes. A node here means a machine with CPU, memory, temporary storage, all will be available. So this particular Spark environment, generally people were using, but whenever Databricks came, this particular environment became one of the like a platform to directly use without installing any of the softwares. But before that, people used to build environment. Environment, a Spark big data environment means we need to install so many things. But after Databricks came into the market, all got sorted out. Everything will be ready. Platform as a service. We have so many platforms available as a service, like OpenShift, for example. Similar to that, this Databricks is also a platform as a service. And the ecosystem with Spark along with Python, which is called PySpark. This is one of the popular framework now in the market to leverage all the Python libraries directly to pre-process the data that is available in the big data environment. And why PySpark? There are so many reasons why people going for PySpark also. It is very simple because of simplicity is one reason, because Python is one of the easiest language and that particular language with the Spark integration is making more readable and concise code compared to Java and Scala. And as you know, how Python is very easy to implement most of the things. So Python with Spark will give more flexible and in-memory computing capabilities. So where you can easily go and implement data science and data engineering activities. That is the main importance of the PySpark, why people started leveraging. And if you go and see the fundamental backbone for Spark is also like RDD. I'll discuss about what is RDD in detail, but RDD is a data set which is called resilient distributed data set. So this will store the data, and which can store even unstructured data also, which is like unstructured data means a text file or a document. So a unstructured data also I can store and I can process if I go and use RDD. But what if I want to store structured data? I will use a data frame. A data frame is similar to a pandas data frame where we can go and store the data in the form of rows and columns, and we can process this data with a distributed collection of organized data with some column headers, like column names. And most of the like features what you see here, these are all like which we'll discuss in detail. So most of the ETL and machine learning tasks people use this data frames and data sets available in the PySpark environment. So we are talking about PySpark and Databricks, all this, but how can we start using that? What if I want to use and how to go and leverage? So we saw like Jupyter Lab. Jupyter Lab is one of the like platform which helped us to run Python code, and we implemented some of the data preparation activities, and we ran some commands related to pandas where we leveraged different functions of pandas, and we leveraged like pandas aggregation, pandas merge, and we saw so many activities whatever we did with respect to data frames. And here also we can do that, but we can do in a large scale. So when I say large scale, your data volume can be higher than what we used in Python. So Python has some limitation. So here we do more than that. So generally, my data it can be here distributed mainly, where we go and distribute the data into like different nodes across the cluster, and which will be processed parallel. And that is how generally people go and leverage, excuse me, like this particular platform. So to understand, so Databricks, we need to go and leverage particularly this uh, PySpark, where we're going to use for the implementation and all. And let me go for the Databricks platform. So we have the Databricks.com. So generally, so Databricks is coming up now with a free edition as well, which you can directly start with. Which you can go and try that. So you can start with like no credit card required, nothing is required. You can directly start with your Gmail. You can continue with your Gmail, and you can start creating your account. And just log into So we have document on how to create this account. I'll share that, which you can follow and create. So this is basically the Databricks environment where you will see like multiple tabs in the left hand side. We have like a workspace, which is basically whenever you want to start working on this platform, we need to create a workspace, and this workspace is a combination of different components here. And you can see here a compute. Basically, this compute is nothing but the Spark cluster, which you can create. But here, Databricks started giving a serverless compute, which you can directly go and use it. And we need to go and start it if at all you want to use it. So here it is, as of now, it is stopped now, and you can start it. And initially, it will be not started. You will need to start. And you can also see in the left hand side, you have like some tabs for SQL operations also. And along with that, we can see the AI and ML capabilities in the left hand side. So most of these particular activities, which are common activities which we do, and to start with this PySpark environment or a database environment to use PySpark and all, you can start with a new like a notebook as well. So Jupyter notebook, which it will go and allow me to start with, and it will be part of the workspace. So it is already there. Let me go to my workspace. So you can see here, I'll show some basic like data frame commands. So it is already there. We do not need to install PySpark here. PySpark will be already available. So here we need to import. See, if you go to any particular like PySpark or Python development, right? You need to import some of the libraries, which we already discussed about. Pandas we imported. 5 different functions we loaded and we started using it. Similar to that, we need to load or import the Spark session here, and need to create a Spark session object here, and then that will help me to submit my Spark jobs to the Spark cluster. So first we need to go and create a Spark session here to initialize my Spark environment, and then you can go and create a Spark session which got created, and this is what my local Spark which got created in the Spark session. And here I want to load, I have a file available, so we can upload the file here by using this upload button, which is available here. We can use this import also. So I uploaded some file, I'll show how to upload. And I want to load this particular CSV file, which is a CSV, and I want to load into a PySpark data frame. So I am using which function we used in pandas to load a CSV file. You remember read underscore CSV, right? So similar to that, we use a read dot CSV here, and but here we can also add the options like I want to include the header, and I don't want to use the header as per the data. So I want to use the header as a column header. So we are clearly including header equal to true here. And this is the file I want to load. So when I run this, it will try to load the file which is available in this particular location into this PySpark data frame called df underscore PySpark. So it is trying to leverage the serverless compute here, and it will try to load whatever the data available in this particular CSV file into this particular data frame. So as soon as it is loaded, we can go and check what are the columns available and what are the rows available. And first we will start with the print schema, which is going to show me what are the columns available. This is equivalent to our D types, which we saw in like pandas. So every column and corresponding data type and whether it is a nullable or not. So we are able to see every column and corresponding type of data type. And coming to like other commands which we can go and work on, type is going to help me to find out whether this is a PySpark data frame or not. We can check that one here. So it is clearly showing me this is a PySpark data frame. And apart from that, we have a command function called show, which is similar to our head. Head is basically will help us to display the top 5 rows by default, but here show is going to show us directly the top 20 rows, which you can see. The top 20 rows it will display by default, and which you can see here. And if at all I want to display only specific columns here, I will mention like total bill, tip and time, and I need to use data frame dot, I use select function, and here I am adding the column names. I have so many columns in my data frame. I can select only, we use this particular option by using like LOC and ILOC functions in pandas. Similar to that, the select function is only going to select the column which I want, and on top of that I'm applying a show, and this is going to show me the top 20 rows of these 3 columns. It's not going to pick up every column now. Total bill, tip and time, only 3 columns it is selecting. So like that we can go and say D types, which is going to give me the column name and corresponding data type also here. And describe is basically going to help us to display the fundamental statistics of all numerical columns, whatever available. We have some numerical columns like total bill is there, and then tip is there, and then size. These 3 columns you can consider, and it is going to give me how many total rows are there, and then what is the average total bill or average tip and average size here, and it will give the fundamental statistics of each numerical column. That is the nature of describe function. And we have like with column and with column renamed. These are going to help us to create new column. For example, with column is helping me to generate a new column from the existing column here. So I am trying to create a new column from the total bill column where I'm giving a discount of $2 minus 2. So this is going to generate a total bill after discount column after size here. When I run this, it is going to generate a new column, which you can see. The show is going to show me now a extra column at the end with name, total bill after a discount if I run this. So which is showing me like this. But I don't want to see the name as total bill after discount. I want to rename this column with maybe final bill. Then I use another function called with the column renamed here. See, with the column renamed, and I want to replace the total bill after discount column with final bill. So this is going to rename the column, and it will display my column name as final bill, which was a total bill after discount after size. You can see now it has been changed to final bill. So which means that we are renaming the columns here. This is also one of the tasks which we do generally. We are rearranging the columns, renaming the columns, selecting the column which you want, selecting the rows, top n number of rows. So most of these operations generally we do after we loaded the data to validate. Correct, no? So we did all this generally with pandas, but we are now performing using PySpark as a framework. Are you following, Jahnavi?
Yeah.
So we did with the pandas. Now we can also do the same using PySpark also, but in
Yeah, I
different,
think the same, I mean,
almost
syntax for both.
almost, but a little bit different functions also available. We'll see that anyway.
Okay.
But whatever you did along with pandas, so we can do everything here. But we will have some additional functions also available, but we'll see what are they.
So
Why?
do we have any change, like any difference, like between pandas syntax and this
So
PySpark?
pandas is basically a Python like native library, which will have some limitations over the data like volume and scalability side, if you see, it will run in the memory only, right? Directly.
Oh, yeah.
If your data volume is too high, it cannot even manage. If you come and
Oh,
see in the Spark side, you will have a compute, this serverless compute, whatever you see. This is going to helping us to run this, whatever the commands we are submitting. So it will provide the resources what needed directly.
so no need to like load data into PySpark.
We can load, but while processing, I'm talking about. We
Okay.
need to load, but while processing, we are using a high level compute here. The serverless or whatever it is, that is nothing but a group of machines, more than one machine. But in when we are using pandas, we are directly dealing the data in the computer RAM only, right? Correct or not?
Yes, yes.
But we are not using any high-end cluster there. But here we
Exactly.
have an option where this platform is providing. We can create our own compute based on our configuration. We can create. If you want a high-end also, you can create. And then you can go and leverage every time when you submit a command, it will go and use that particular cluster. And even my data volume is, I can even load like JSON data, Parquet data. So we have so many benefits compared to, because it's a platform. See, not only that, we have so many other features also, like directly we can deal with. Like what you can see, like is a AML playground is there. So this is just like a interface, right? Generally. So since interface, we have all features are integrated in one location. So we can directly go and use all of the data I centralized here. I can use directly in my data science applications here directly. So this is a data science platform, like which can say data playground, and I can use whatever data I generated here in this particular process. I can use here directly. So which means that everything is one place where I can use my whatever my data I generated for my ML activities, and I can go and use even some data maybe in the SQL data warehouse also. So this platform is going to help in that way. But we'll discuss in detail about it, but high level I'm explaining today. Okay?
Yeah.
So Uma, are you following Uma?
Yes, yes.
Okay, cool. I think Prasanna, you already have some knowledge on this, but maybe
Yeah.
so I hope you already familiar with this. But I'm just a recap because Jahnavi is new to this and Uma also new to this. Okay, so I'll try to share this particular uh, Jupyter notebook and also the PPT, which you can try to create this account and log in with your credentials and try to run and I want you to see today. Okay, Jahnavi, Uma and Prasanna.
Right. Here.
Yeah, because it's just like a starting point, right? We will go and
Correct.
try to learn all one by one, and which we are jumping into the actual like environment to see how we can leverage it and uh, get benefit of the Databricks, and we also go and see how to integrate with the Azure side also coming days. Okay,
And I think it will be more interesting to see when building delta tables and different kind of tables, and
we will
that
see
will be
that.
more.
Yeah, we'll see that. Once we'll get some familiarity with this fundamentals,
Correct.
we'll go to delta tables, all this definitely.
Yeah.
Sure. Okay.
All right.
Okay then. Thank you so much. That's all for today. I'll share this and please wait for the Google will be ready and I'll share. Okay.
Thank you, sir.
Okay. Thank you so much.